Alright guys, so moving on, we're going on to our next topic here. And in the previous section, we were talking about direct variation. And we were using this equation for direct variation. Okay, so in this topic, we're going to be talking about joint variation. Now, joint variation is just like direct variation, okay, except with joint variation, we have two or more variables, okay, for our x value here. So with direct variation, we only had one variable, okay? But with joint variation, there's going to be two or more. But we can still use this same equation here to solve for joint variation. So joint variation is a type of direct variation, right? So joint variation is a type of direct variation. Joint variation, however, has two or more variables, okay? So let's go ahead and read the problem, and then we'll talk about how we can set it up. It says the area of a triangle varies jointly, okay, as the base b and the height h. It says a equals 12 meters squared, the base equals 6 meters, and the height equals 4 meters. Okay, and then it says find the base when a equals 36 meters squared and the height equals 9. Well, you're going to go about solving this the same way you were with direct variation, okay, except now we have not just one variable, we're going to have two. Okay, so again, the first step you want to do is solve for our constant of variation. So we're going to plug it into our formula. So if you want here, we can rewrite this, right? What is y going to equal? Well, y is going to equal here my area. So I can replace that with my area. So I can write here, let's do this, area equals, and then we'll have our constant of variation, right? But here on my x, right, I'm going to have two variables here. And what are those going to be? Well, that's going to be the base and the height. So I'm going to plug that in. So base and height. All right, and that's it. Now we can go ahead and plug this in. All right, so same kind of principle of how to go about solving this. Okay, just a little bit different. So we're going to go ahead and plug these numbers in. So we're going to have 12 equal to k times my base here, which is going to be 6, my height, which is going to be 4. So we get 12 equals 24k, and then we're going to divide both sides by 24. Okay, so k here is going to equal a half. All right? Well, knowing that, let's go back and see what it's asking us. It says find b when a equals 36 meters squared and the height equals 9. And that should be 9 meters. Okay, so all we're going to do is plug this in now. So let's go ahead and do that. So the area is 36. My k value is a half. All right, my height here is going to be 9. And my base, we don't know, we'll call it b, right? So let's go ahead and plug this in. We get 36. 9 times a half is going to be 4 and a half. So we have 4 and a half times b. Divide both sides now by 4 and a half, and that will give us our answer. So when we do 36 divided by 4 and a half, you get 8 here. So your base will equal 8 meters, okay? And that will be your final answer. Okay, let's try another example.